This is class activity 12B, where we're going to be cutting rectangles into triangles. It's on page 274. All right, you will see from the directions on there that you are supposed to have some rectangles here. Let me trim this one up. All right, so here you have one rectangle and you were to replicate it actually 7 times. And I want to show you, give you a good idea of how to do this. So for each of these rectangles, you cut them out, make them as close in size as you can. I'd recommend you putting FA and FB and BA and BB, like just recommend that as a way to keep them organized, front and back. And then what you're going to do is you're going to take each one of these and you go corner to corner and cut out triangles. All right, so you cut all these triangles out. And then this one right here, you can cut it out also, but that's really just going to be the basic shape. I didn't even label this one. So you want to make 6 different shapes now, and you have 7 of these rectangles, and I'll show you what to do the 7th one in a minute. So here's the first rectangle, and you cut it into 2 triangles, and that's one shape. All right, so that's one of the fronts. We'll call that front, and then I'm going to pick 2 more of the fronts, and then I'm going to take these 3 and make them the backs. All right, so basically what you've done is, for this one right here in the front side up, you've matched, since it's a rectangle, these are both right triangles, so the longest side is hypotenuse, you've matched the 2 hypotenuse together. Okay, so now for this one, we already done the hypotenuse, we're going to match the shorter leg together, okay, because each of the sides that form the right angle are called legs. So here's the shorter side together, and then what we're going to do is we're going to match the longer legs. All right, so there's 3 different shapes, only the fronts. So now the next 3, I'm going to do 1 front and 1 back. So if you can see that that's a front there, that's another shape. So now you have a 4th shape. That's the front and that's the back. I'm going to match the leg together. That's another shape. Okay? And then I'm going to match the long leg together, and there you have another shape. So you've got 1, 2, 3, 4, 5, 6 shapes. 3 of them just the front side, 3 of them the back, matching the like sides together. Hypotenuse, short leg, long leg, hypotenuse, short leg, long leg. All right, so now there is the last one where you're supposed to take the square, this square right here, and cut some odd shape out of it. So I did something similar to the book. I had my square and I cut my odd shape out, and I have this right here. So now I have 7 figures all made from the same square. They all have the same area, even though they are shaped differently. All right, so that's the major question. Now, this right here is when I've done all these shapes and I have calculated the perimeters. I measured each of my squares, and that was 5 by 7. So notice its still area is 35 centimeters, but its perimeter is 24 centimeters. Notice this is centimeters squared, because area is squared, perimeter is a linear measurement, it's just a single, one-dimensional. Here's another figure that I have. Area is 35 square centimeters. Perimeter is different though, 27 2/10. All right, I had to use the idea of the Pythagorean theorem to find the sides, and then we'll be dealing with that in 12-9. Here's another shape. My area is still 35 centimeters, and my perimeter is 27 2/10 centimeters, like this one. Even though they're shaped differently, they actually happen to have the same perimeters. Here, my area again is 35 centimeters squared, and my perimeter is 31 2/10 centimeters. We're using the Pythagorean theorem and figuring out what the lengths are. So area is the same on all 7 of these. Perimeters, there's some differences here. This one, the perimeter is 24, like that one up there. Area is still 35 centimeters squared. For this figure right here, area is 35 centimeters squared. Perimeter is 31 2/10. Now my last one, area is still 35 centimeters squared because I started with the same rectangle for all of them. I just moved the parts around. And that part right here, I have no idea what the perimeter on that is. You'd have to go in and measure every little tiny bit and even then guess at it. So the understanding of this problem is that the area of a figure, no matter how you cut it and move it around, is going to be the same for all of its different ways you make it. All right? However, the perimeter does change. So this is activity 12B.